Hello. Okay, so I uploaded the project from yesterday, last night, because I didn't like the video. The video was a bit crap, and I didn't really go through very much in good detail. So you could basically just go to the link that I'll give you and download the folder if you've had problems with the last video. You want to, well, these are stuff from uni. So here's what you'll get. Now I've got a drive set up already. It's the same one as I was using before, only I've just called it repo instead. Oh no, that's the one with the actual repository for GitHub. So deleted that one, that's where I want to put it. I don't need these two, although I recommend you read the README because you guys are going to need to link the libraries. It's a very similar process. I think I've opened up in the wrong version of Visual Studio actually, 2019. So we're just going to quickly look through the window, see if there's anything wrong with it, and then create a class for drawing for indexed drawers. But first we need to make sure it runs. So if it runs straight away, I'll be amazed. What? Well, that shouldn't happen. Okay, for most of you guys, you're going to need to go to properties and link the folders like we did in the second video, I think it's called, link in the libraries, and yeah, so that you set up the solution directory with, you know, libraries, get glad, GLM and everything like that, and the linker as well. And in the preprocessor, don't forget to put in the console glfw include none, because otherwise you'll have a problem with glad and glfw working together. Anyway, that's from the second video. So we'll quickly go through the window because I'm sure I've got something wrong somewhere. I feel like it's somewhere around here. I remember going to sleep thinking, hang on, that's wrong. glfw. I think this one's supposed to be just GL true rather than glfw true. I wonder what if the difference is. glfw 1 and GL true is, I bet it's 1. Okay, yeah, so nothing major. Let's go to the, oops, that's glad, we don't need that. Well, we do, but you know, we want the window header. Because I changed the buffer height, but I don't think I changed, yeah, so these two need to be GLUints rather than GLUints for the functions get buffer height and get buffer width. Anyway, I think that was everything. There wasn't really, I mean, it runs and it's working, so we should just trust it for now. If we run into problems later, then we do. So what we're going to do, we're going to include our own header called, what should we call it? Let's just call it object drawer. Why not? We haven't actually got that yet, so we'll go to right click on the folder, the project, that's what it's called, sorry. Go to new, or add, sorry, class, and we want it to be called object drawer. Ooh, not implemented. What's happened? It seems fine. Oh, maybe something to do with that. Who knows? That was very strange. Public, private. Oops. We want a default constructor drawer. We want a deconstructor. We want a void draw function. We want a, I'll put it underneath that. We want a void create object function. We'll fill that up in a minute. Yeah, don't create any of these yet. What else do we want? Oh, in the privates we want, actually better include glad. I don't think we need anything else, so for now, GLUint, we want the vertex array object, vertex buffer object, and index buffer object. everywhere you look, actually, this is referenced as the element buffer object, so we'll change it to that instead. But it's basically indexed for index drawers, and we also need number of indices. So imagine these as postcodes, I guess, just addresses to locations on the GPU. That's what these are going to be. So we'll create the default constructor for BAO equals 0, BBO equals 0, IBO, EBO equals 0. Number of indices. Number of indices equals 0. Come on. Okay, so we just initialized all those. The deconstructor we can just create for now. Create the thing for. Oh, don't create that. My bad. Take that off. We need to add some stuff into there first, but we can just create that one. For this one, we want to pass in some GL float arrays. Let's call these verts. GL int. No, uint of type. And we'll call those indices. And then GL int number of indices. Now we can create it. If there's anything else we need to add on to that, we can just put it on the end afterwards. Now, what are we doing with that? So I like to keep things nice and tidy. So for now, we'll start making it. So we want an object drawer called object, or just obj. That's fine. And we want to create the arrays that we're going to use to create an object. So from now, we'll quickly go over to this website, which is fantastic if you want to learn some OpenGL stuff. I say some stuff. This goes through a lot. It's really good. And we're on Hello Triangle, which is basically drawing your first triangle. We'll go down, and you can see it's got information on vertices, generating the buffers, binding them. So check this website out. It's brilliant for understanding what's going on. I won't go into too much detail, but I will be showing you how to understand some functions. Like, I mean, how are you supposed to know what this actually does? You know. So I'll give you a bit of a guide on what to do for that. I'm going to go all the way to the bottom, where we have the source code, and this is what he's using to build their square. I think they're making in this. Yeah, there you go. So you can see there's a lot of code. That's why I like to keep it all in classes, because it makes it nice and tidy. They're using GLAD, GLFW, like we are, so that's great. In fact, it looks like the course that I took is massively based on this because of the way it's all so similar. But I'd imagine everything to do with OpenGL is very similar, really, when you think about it. So, what are we looking at? We can ignore those for now. This is just the screen height and width. These are some functions that we don't need to worry about yet. So I think this part we've done a different way, so we can ignore that. We've got two shaders there, a vertex shader and a fragment shader. We're not going to include those yet. We're relying on the GPU to know what we're drawing, and there should, because we've got in our main function we've got clear color here, and we can choose the color. When we draw the triangle, it should be just on that, not that color, but just white or black on that color, if that makes sense. So it'll be either a black or a white triangle on whatever color background you've put here. But this is basic. These are really, really basic shaders. What they're doing is just setting the, well, I want a nice and easy way of explaining it, but I think what I'll do is I'll go up and down to kind of go through it. You can see they're setting up their window, so we can skip all this part. Setting up the window still, loading up GLAD, we've done all that. They're setting up the shaders here. We haven't done that yet, but we don't necessarily need to. Hopefully you can all your graphics cards will support drawing without setting up the shaders, but there's a very small chance that Some of you might not draw at all. Should be fine. Now then, we've got the vertices here that they're creating a square. We've got top right, bottom left, top left. There's 1, 2, 3, 4 points there. With standard array drawing, you'd need what is it? There's 2 triangles, so there'll be 6 points. So 6 times 3 is 18. Yeah. So usually you would need 18 vertices to draw a square, but with index draws you can see we only need 12, and we're only going to be drawing a triangle, so we're going to have 9 vertices, 3 indices. And you can see that they've got their VBO, VAO, and EBO there. They're generating the vertex array object, vertex buffer object, element buffer object, binding all the data, and then down the bottom here, they're drawing. What's quite interesting here is they're drawing without calling the element buffer object, which is what we're going to be doing in ours. Interesting. So let's go over to ours and start writing. Go over to create object. So first of all, really easy. Number of indices equals, that should not be called the exact same thing, number of ints. So just like I said, go over here, we'll just copy this bit here and replace that because that's not, yeah, not bad, be being silly. And now, GL generate vertex, is it? GL gen vertex array, and we just want to pass in 1 and the vertex array object. So what we're doing here is we're generating a vertex array on the GPU, and we're getting the address of that array. And the best thing to do if you're not ever sure of a function you're calling is to Google it quick so you get some good information. Here we've got GL size I, n, so that's just how many you want to generate, it says it there, and then the arrays, which is our reference to the, that's why you can generate more than one. So if we wanted to have more than one, for example, with the VBO and the EBO, we could make a funny way of doing that where we're basically just going, what should we do? No, actually, we won't overcomplicate this. Basically, you can make as many as you want and have an array here instead of just a reference to one variable. So I'll tell you what, I will quickly show you. So if we were to go int, well actually, yeah, just go int, and we want buffers, we'll have 2. We could go, I mean, I haven't initialized that or anything, but if we were to go GL gen buffers, want 2 of them, we can just pass in buffers, and you can see that got, no, they do need to be GL UN or GL ints. There's unsigned ints they need to be. Come on, man. There we go. See. So yeah, that's basically if you want to generate multiple at the same time. But what we just want to do is keep it nice and clean. Go GL gen buffers. We want 1, and we're going to do the vertex buffer object. And then we're going to do GL gen buffers 1, the yeah, EBO. My bad. Yep. Okay, so generated the buffers that we need and the array. Now then, what are we doing next? Well, GL bind vertex array VAO. Nice and simple. Let me quickly show you what that does, rather than just know what it does. Specifies the name of the vertex array to bind. So this is basically like, now we have the address of this, how to put this, binds a vertex object with a name, name array. Array is the name of a vertex array object previously returned from a call GL gen vertex arrays, or 0. So basically we're binding this array so that we can assign the vertices to the vertex buffer object once we've allocated the space using GL bind buffer, GL buffer, oops, say what, we'll look for this one as well. GL, so we want the target, which is going to be array buffer. GL array buffer, and we're just literally passing the vertex buffer object. So now we have generated a vertex array object on the GPU, and we have a vertex buffer object, which is what we needed from the this. Apologies if I'm going a bit quickly and actually stumbling over many of my words. We're basically binding the vertex array so that we can bind it to the vertex buffer object and then pass the data onto it. Right, so bind buffer data next. We want it to be of type GL array buffer, and we are going to specify the size, which is size of, and then the vertices. Oops, verts, I've called them in this. What's interesting is before, when I was doing this, I had the verts being passed in and the number of verts, and what I'd do is do verts, the first value in there times the number of verts coming in, and it seems that you don't have to do that. You just have to pass in the size of verts, which is the size of the entire array. It doesn't really make sense why the way I was doing it the other way, but that's the way I learned to do it, I guess. So then we pass in the verts, and then the usage. So you know what we're doing, we're going to have a look what the usage actually is. So the usage specifies the expected usage pattern of the data store. The symbolic constant must be one of these values. And these values are made up of stream, static, or dynamic, and draw, read, and copy. And it shows you down here what each one of these does. So stream, the data store contents will be modified once and used at most a few times. Static, the data store contents will be modified once and used many times. Dynamic, the data store contents will be modified repeatedly and used many times. So we're not going to be modifying the values once we pass them into the shaders. So we don't want it to actually be modified. So we don't need to worry about them being, and we need to use them multiple times, so we might as well keep them on the GPU. So we're going to be using static, which means they get passed onto the GPU and they stay there until they're deleted. So static, and we're going to be drawing with them. I mean, that's kind of self-explanatory. Read is quite useful for, well, you can see what it's useful for. Reading data from the GL, used to return the data when queried by the application. So there's basically like reading data from the GPU using the CPU. So you can pass things, I'd imagine, like calling information from the GPU in a print function to a console, which will make it, you know, it gives you a bit of control over seeing what's wrong and where it is wrong. But all we're going to be doing is draw, static draw. So GL static draw. Okay, I probably didn't need to go into that much detail, but you can see why it's useful to just quickly Google the function. Okay, now the GL bind buffer, GL element array buffer, and we just pass in the EBO. Now, why do I know how to do this bit? Bind buffer's right there. Got GL array buffer there, which is what we did for the vertex attributes, which are the verts that are being passed in. So the vertex array object, the vertex buffer object, that's what we want. And then the next part is the element array buffer, which the vertex array indices, which is what we want, so we can do index-based draws. So that's where we're binding this buffer here. And then we pass in the buffer data, GL element array buffer, the size, so that's size of indices, and the usage, GL static draw again. So now we've bound the information for the vertices and the indices to the GPU, assigned the vertex buffer object and the element buffer object, and the array object so that we can draw using just the GPU now. But what we need to do now is tell the GPU what to do with that data. So this is where you would pass the information into the shader, but we don't have shaders yet. So we don't need to worry too much about it, but I will go into more detail later on when we come back to this function to add to it if we need to, or just to show off what you can do really, because the important thing about Opengl now is that you can just get in and play with the pipeline, and that's where you get some of these really cool nice particle effects, where you've got like loads of fluid simulation like on screen. You're just kind of like, how on earth is that happening, rendering at such a fast rate? Anyway, that's where it gets exciting. We'll just focus on this right now. So after we've done that, GL vertex attribute pointer. I probably should know why we go to that bit. Here we go. So after we've bound all the so this is from the hello triangle thing again. After we've bound the vertex array object, vertex buffer object, and element buffer object, and all the data, we want to enable and set the vertex attribute pointer. So GL vertex attribute pointer index is going to be 0. The size is a 3 for x, y, and z of the array that we're passing in. So we've got 9 values in there, for 1 for each point of the triangle, and every point of the triangle has x, y, and z for the coordinate space. So we're passing that in 0, 3, and then the type is GL float because that's the type of data in the array. Normalized, we don't want it normalized. GL false. The stride. This is the the stride is x, y, z. So we've got 9 values in the array. 3 values is the stride for x, y, z, and then x, y, z again, then x, y, z again, kind of thing. So size of that's 0. So that's 1 value in the vertex array times 3. So that's the x, y, and z done. And then the pointer, we don't need that yet because we haven't got any other data in that array that we need to be using. If you had, for example, 5 bits of data per vertex, you'd put 5 in there so that it knew to skip over the next 2 values to get back to the first value. So let me show you quickly. We haven't got. So let's say we had x, y, and z, and then just u and v. For you'd want it to do x, y, and z, and then just ignore these 2. So the stride would be 5. But when you got so this would be 5 here. But if you had another one of these for the let's just copy it quickly and show you what I mean. For the 2 other values on the end, u and v, then you would have 2 for the number of values that are actually being processed, and then this would be 3 basically. But there would be a bit more information in there. We'll go through that in the future. It's quite quite clever. Right, now I've purposely left something out, but we'll get back to that in a bit. GL. So now we want to unbind so that we're GL bind vertex array. We want to unbind so that we're oh yeah, that's just 1 value. Not bad. We want to unbind so it's nice and clean now. GL element array buffer 0 and GL and buffer GL array buffer 0. So now we've just unbound the ones that we just had bound here. And then when we draw, we want to bind the vertex array, the element array, GL draw elements, not arrays, GL triangles, the size of the triangles, which will be number of indices, size of the triangle, size of the array, Then what have we got? We got type GL unsigned int and 0 for the what's wrong with that? Oh, I'm signed wrong. And bind buffer IBA. Why is that not? Oh, ABA, my bad. And then right at the end we'll just unbind again, but we don't need to unbind that one because the element array buffer is now referencing the vertex array buffer through the indices. Okay, so we don't need to we don't need to bind the vertex array the vertex buffer object anymore. Now we just need to create a deconstructor. The deconstructor, if VAO is not equal to 0, then that means we've bound a vertex array object to the GPU. So we want to delete vertex, come on, GL delete vertex arrays, VAO, this is a reference. And then we want to do the same thing for the buffers. VBO not equal to 0. GL delete buffers VBO reference again. I always forget the reference. And then the same for the index. So if GBO is not equal to 0, GL delete buffers and oh, maybe it isn't a reference. Oh, it is. Hang on, my bad. I haven't put in the number. We want to delete 1. We don't want to overshoot and, well, this is just the way the function works basically. So we've got the create objects, we've got render the objects, and we've got the deconstructor as well. So now that we've got the object there, we just need to create some vertices and indices. So we'll do a GL float array of verts. We'll just call it same as the thing that we're passing into. We want 0f. No, we want 0 minus. Yep, we go. Just read rather than hear me talking because I jump over my words like a madman. And then we want 0.5, 0, and then we want 0.0, 0.5, 0.0. And this is just a triangle. So you got the bottom left there, the bottom right, and the bottom, and the top X. Y, Z. I suppose that makes it a bit more easier to read, right? X, Y, Z. I mean, there you go. Now, GL U. Oops. Then we want the indices, ins equals, and then we want. So how's this going to draw? I want to do it in anti-clockwise because that's just best practice. So bottom left there, bottom right. So that is anti-clockwise anyway. So we can just do 0, 1, 2, except for the sides. So we're doing that one first, then that one, then that one. And then object dot create. Oops. Object dot create object. So that's just the class we created earlier. We're passing in the vertices, the indices, and the number, which is 3 of the 3 indices. Okay, and then draw. So we want GL. No, we don't. Object dot draw. Now, if you remember, I purposely left an error in there, one that annoyed me earlier, and I'd laugh if, yeah, it didn't draw, didn't think it would. What haven't we done? Now this was very annoying. I spent about half an hour trying to find it, so the video ended up an hour long. So we're going to quickly show you what happened, because most of this is just I don't know if you've noticed, but most of it is literally just what's the word I'm looking for? The one where you're just making up as you go. That is literally how it's going. So what have we done? We've generated the vertex array objects, buffer objects, element of buffer objects. We've done all that. we've got those three here. We've bound the vertex array object and the vertex buffer object with all the information, and that's pretty much identical to here, which is quite impressive considering. The element array buffer object, that's all identical. Vertex attribute pointer, bind the buffer. So we've unbound the buffers down there. Did any of you spot it? For a start, that's not supposed to be that. Does that fix it? I doubt it. Yeah, I think so. Nope. Here it is. This is the point I missed, and I can't believe I missed it either. I mean, considering. Right, vertex GL enable vertex attrib. Is it array attrib or attrib array? Look at that. Let's guess it's that one. GL enable vertex attrib array. GL enable vertex array attrib. Damn it! The other one attrib array 0. What is that? That's the same as this. So it's basically enabling this position on the shader. And I'll show you what that is now that we've completed it. So we go up to the shaders that they've written in the string. Layout location equals 0, a position. So this is the position of each vertex as it's passed into the shader. That's what this is. And you could write multiple of these. You could lay out one in vec2 texture position, textual coordinates even. You could do a vec. You could just do a float even of just, for example, a distance. So you've got the distance field passed in for some reason for each vertex. I mean, that's the point, is that you can now, with OpenGL, modern versions of OpenGL, this is just version 3 actually, you can really customize the shader pipeline, well, the pipeline with the shaders and passing information to the GPU. So this will run now. It didn't run. What has happened? GL program 0. Done something wrong somewhere. I'm not spending half an hour again finding it. Right. Got the object. Creating the object, passing in the verts, and then we draw. Did we make a draw function? Did I? No, it's there. What are they doing in this one? I know they're drawing arrays, which doesn't technically use the IBO, which is interesting. GL unsigned int. Number of indices, GL triangles. Oh, didn't change that back. That needs to be 3. Still not drawing. Maybe this needs to be -1. And that doesn't have an F on the end either. Still nothing. Oh dear. Let's reference my other virus, Visual Studio. Let's reference my other project and see what's missing, because this is nearly identical. Oh yeah, I did this, which is slightly different, size of rather than. Right. Yeah, so with the vertex attribute array, what's the draw function like? GL bind vertex array object, bind buffer elements, number of indices, underlined int 0. So this is identical, the draw function. that's the wrong program. So we're creating the object there. This is weird. Come on, man. Size of GL float, maybe? I doubt it. The vertex is a float, so yeah, I didn't think so. Change that back. Vertex attribute pointer 0, 3 GL float, fast 0, 3 GL float. This is crazy. Cannot see it. Sorry guys. I'll probably skip over this until I find it because it's definitely in this draw function. It's not going to be anywhere else. Unless it's in depth. Okay. Oh, we haven't got that enabled. It's going to be an error. Or not. It should be an error. This is annoying, this is. I think there's 9, and then size of indices 0 times number of indices. Let's see what happens there. I doubt that's just going to make it work there. Oh, well that's strange. So that kind of means maybe vertices is fine on its own. Nope. Very strange. Okay, so let's get rid of the bits that I changed then. So I didn't use that, and I didn't use that, and that was the problem there, which I think is really strange considering the other. So it doesn't like it without the depth buffer either. So it has to have the depth buffer. We learn new things all the time. Unless it's GLUG's program 0 that's missing. Nope, it's the depth buffer. Weird. Well, there you go. We've got the triangle. Sorry about that last problem. I would cut it out. I probably can cut it out once I put it up on YouTube, but yeah, very strange. So for the buffer data, you do need to put the size of the vertice the initial value times the number of vertices you've got coming in. So I need to add in quickly GL in number of verts there. We'll add this onto the object drawer part, and in here then we need to add 9 in there, and then when we go back to this one, instead of 9 here it's number of verts. Ah, that's annoying. This one can stay as free because this is specifically for the shader, and we're never ever going to not have 3 vertices to draw. Yeah, apologies for that annoyingly long error. As you can see, we've got our first triangle now, so we'll be making the shaders next, and they're a little bit tricky because we have to use a file stream and stuff, but it'll be good fun, I promise. Once we've actually got the project set up and that, it's going to be good. So, see you in the next one.